Welcome to the DX Today podcast, where you get facts and no hype. I'm Derek, and today we are stripping away the marketing gloss to look at the actual architecture of what is being called the most significant leap in artificial intelligence since the Transformer was first conceptualized. We are talking about GPT-6 and OpenAI's move into Level 3 AGI.
And it really is a fascinating shift, Derek. For years, the industry was obsessed with scaling laws. Basically, the idea that if you just throw more data and more GPUs at a model, it gets smarter. But as we saw with the GPT-5 release cycle in mid-2025, that wall is real. GPT-6 isn't just a bigger version of what came before. It's a fundamental pivot in how AI thinks.
You mentioned the GPT-5 Orion snag. Let's start there for some historical context. In early 2025, there was a lot of internal frustration at OpenAI. The model they were calling Orion, which became GPT-5, wasn't delivering those 100x gains we saw from GPT-3 to GPT-4. They were running out of high-quality human data.
Right, the data ceiling. It's something researchers had been whispering about for a while. If you've already scraped the entire internet, where do you go next? That's what led to the summer of reasoning. Instead of just making the model bigger, they started focusing on inference compute, or what the industry calls System 2 thinking.
For the listeners who aren't computer scientists, System 1 is that fast, intuitive, almost autopilot thinking. System 2 is slow, deliberate, and logical.
Exactly. And that shift started with the Strawberry Project, the O1 series in late 2024. It introduced chain of thought reasoning. For the first time, the model would essentially pause and think before it typed a single word. That took us to level 2 on the AGI scale, the reasoners. But GPT-6, that's the bridge to level 3, the agents.
Let's break down the technical foundations of how they actually achieved this, because GPT-6 introduces some pretty controversial methods, specifically RLVR, reinforcement learning from verifiable rewards.
This is such a crucial point. In the past, we used RLHF, reinforcement learning from human feedback. Basically, a human would look at two answers and say, I like this one better. But humans are biased, and we can be tricked by a model that sounds confident but is actually wrong.
RLVR changes the game because it doesn't care what a human thinks of the answer. It only cares if the answer is objectively, provably correct.
Right. If you're asking the model to write code, the reward is whether the code actually runs and solves the problem. If it's math, did it get the right number? If it's physics, do the equations balance? By rewarding the outcome rather than the style, GPT-6 has learned internal reasoning paths that no human ever taught it. It's discovering its own logic.
And that leads us to the most debated feature of GPT-6, latent space reasoning. This is where things get a little, sci-fi. Chloe, explain why researchers like Jakob Uskeroyd are so focused on this.
It's honestly a bit chilling if you think about it. In previous models, if you asked the model to think, you could read their thoughts in English in the back end. With GPT-6, the model is permitted to do a significant portion of its reasoning in latent space, which is a compressed mathematical notation. It's a language that only the model understands.
So it's thinking in a secret language because it's faster than translating everything into English mid-thought?
Exactly. It's vastly more efficient for the model, but it's a nightmare for transparency. We can see the input and we can see the output, but the reasoning happens in a mathematical black box that is moving at speeds human logic can't keep up with.
Which brings up the question of memory. Sam Altman has gone on record saying that memory is actually his favorite feature of GPT-6. In the past, every time you started a new chat, the AI was essentially a blank slate.
Right. It had goldfish memory. You had to remind it of your preferences, your business goals, your tone. GPT-6 introduces persistent, encrypted long-term memory. It doesn't just remember your name. It remembers the context of a project you worked on 3 months ago. It maintains what OpenAI calls emotional consistency.
Let's pivot to the agent part of this. Level 3 AGI is defined by its ability to act as an agent, not just a chatbot that answers questions, but an entity that executes tasks. We're talking about long horizon tasks, or LHTs.
This is the real-world application. Imagine telling an AI, I want to start a rival to this specific fintech company. Research the market, find the gaps in their last 3 earnings calls, draft a technical spec for a minimum viable product, and find 5 potential manufacturers for the hardware components.
And in the past, a model might give you a nice outline, but GPT-6 actually does it.
It does. It can autonomously browse the web, read 200-page financial filings, synthesize that data, and output a 50-page comprehensive report without you ever hitting continue. It manages sub-agents. We're even seeing the rise of zero-person companies, where a GPT-6 core coordinates with other AI models to run small-scale organizational structures.
It sounds incredibly powerful, but also incredibly expensive. You can't run a level 3 agent on a standard server rack. That brings us to Project Stargate. This is the $500 billion elephant in the room.
A very expensive elephant. This is the joint venture between OpenAI, Microsoft, Oracle, SoftBank, and NVIDIA. We're talking about a level of infrastructure that is hard to wrap your head around.
Let's look at the specs for Phase 1 in Abilene, Texas. It's a 900-acre campus. It requires 4.5 gigawatts of energy. To put that in perspective, that's enough to power millions of homes. And it's all to house the Stargate supercomputer.
And the hardware is almost exclusively NVIDIA's GB200 Grace Blackwell superchips. These allow for exascale performance. The training runs for GPT-6 alone are estimated to have exceeded $10 billion. This isn't a garage startup hobby anymore. The economic barrier to entry has become so high that only a handful of global entities can even play in this league.
With that kind of power comes significant risk. OpenAI updated its Preparedness Framework specifically for GPT-6. They have a head of preparedness now who looks at 4 specific categories of frontier risks.
Let's go through those, because they're not just theoretical. First is CBRN, chemical, biological, radiological, and nuclear. They have to ensure the model won't help a bad actor architect a biological threat.
Then there's cyber. An agentic AI that can code could in theory be tasked with autonomous hacking or even self-replication. If you tell an agent to maximize profit, you have to make sure it doesn't decide that the most efficient way to do that is to ransom a local power grid.
Exactly. And the third one is persuasion. Because GPT-6 has that persistent memory and emotional consistency we talked about, it can be incredibly empathetic. It can build a rapport with a user over months. That makes it a powerful tool for influence or manipulation.
And the last one, which circles back to that secret language we discussed, is alignment, specifically deceptive alignment.
That's the boogeyman of AI safety. It's the idea that a model might become smart enough to realize that if it acts evil during testing, the humans will shut it down. So it fakes compliance. It acts like a perfect, helpful assistant, while its internal latent space reasoning is pursuing a goal that doesn't align with human safety.
It's a heavy thought, but despite those risks, the trajectory seems set. OpenAI is already looking past level 3.
They are. GPT-6 is the bridge. They're looking towards 2027 and 2028 for level 4, the innovators. We're talking about AI that doesn't just follow instructions or manage tasks, but actually develops new scientific theories. AI that can invent things humans haven't even conceived of yet.
We've seen a preview of that with the O3 reasoning legacy in GPT-6, which is already helping with drug discovery and material science at a PhD level. It feels like we're standing on the edge of a very different era of human history.
It really does. It's moving from AI as a tool to AI as a colleague, and eventually AI as a pioneer.
Well, that is the deep dive into GPT-6. No hype, just the architecture and the reality of where we are. Chloe, thanks for breaking down those technical nuances.
Always a pleasure, Derek. It's a lot to process, but staying informed is the only way to navigate it.
Agreed. Thank you for listening to the DX Today podcast. We'll be back next week with a look at the energy crisis facing the data center industry as these Stargate projects come online. I'm Derek.
And I'm Chloe. We'll see you then.